Hello again, this is MP Live Lessons. Now this time I'm doing a quick tutorial for Chemistry Paper 1. This is going to be on ionic equations. Now we need to first learn about how ions are formed. So first, ions are formed by atoms. They will try to become stable by having a full outer shell of electrons. They can do this by gaining or losing electrons. For example, how does a lithium atom become stable by reacting? So in this case, we've got a lithium atom. This has 3 electrons. If you know how to draw electron shells, you should know that 2 fit in the first shell and a maximum of 8 in the second shell. So we have 1 on its outer shell. Now, what happens is, to have a full outer shell, it can either gain much more, 7, or just lose this one on its outer shell. So it can lose this one, so lose 1 electron. So the outer shell is then the one beneath it, which is already full. So this becomes a lithium ion. Now, since we've lost an electron, there aren't enough electrons, so there's not enough negative charge. So that means when we lose electrons, the ion becomes positive. Now, as a result, you'll need to know about ion charges. So, what we know is that the protons and electrons in an atom have some charges. So if electrons are gained, as I said, the ion is negative, whereas if electrons are lost, the ion becomes positive. For example, since a full outer shell of electrons is usually 8, atoms become ions, for example, with charges. So for example, atoms from the group 1, they'll have 1 electron on the outer shell. So that means they need to lose 1. This becomes a 1 plus ion. Now it's similar for group 2, they'll have 2 electrons on their outer shell. That means they need to lose 2 electrons to become stable, and they become ions with a 2 plus charge. A simple pattern for group 3, they'll have 3 electrons on their outer shell, which needs to be lost, and that means they become ions with a 3 plus charge. Now the other 3 you need to know are non-metals. So these start with, let's say, group 5. So these have 5 electrons on their outer shell. You need to gain 3 to get 8. That's your full outer shell. That becomes an ion with a charge of 3 minus. Group 6, they have 6 electrons, they need to gain 2, so they become ions with a 2 minus charge. And group 7, they have 7 electrons on their outer shell, they need to gain 1, and that means they become ions of a 1 minus charge. Some other charges you may need to know are useful. For example, hydrogen can become an ion by losing 1 electron to become positive. Hydroxides ions are found usually in alkalis, so these make like alkalis what they are, bases, or with a high pH. These have OH minus ions. Some of the ones you may need to know are sulfate ions, SO4, with a 2 minus charge, nitrate ions, so 1 minus charge, and carbonates with a 2 minus charge. Now this links into ionic compounds and bonding. So these are formed when a metal and a non-metal react together. So they react by transferring electrons, so the atoms become stable. For example, 2 atoms of lithium can react with 1 atom of oxygen to form lithium oxide. We can draw this with a dot and cross diagram showing this reaction, and it can show the electron transfer. And I'm going to just draw the outer shell of electrons only. So in this case, we have two atoms of lithium with one electron on their outer shell with an X. And I've got one oxygen atom with 6 electrons on their outer shell, which I'll draw with dots. Now it needs 8, so it can gain 2 electrons. So these two will get transferred. So overall, what we'll have is lithium ions with a full outer shell. These each will have a 1 plus I charge. Then you'll have your oxygen atom. It's 6 electrons, but the 2 it picked up from the lithium ions, or the atoms. And since it's gained 2 electrons, it becomes with the charge of the 2 minus. We can go further and start to look at ionic bonding itself. So this is a common exam question. So describe what's happening in the reaction when 2 lithium atoms react with 1 oxygen atom. And we talk about electron transfer. Now we can't just say 2 electrons are transferred. This won't get you all the marks. So first we have to say that the lithium atoms lose 1 electron each from the outer shell. This makes them stable. That means they form lithium ions with a 1 plus charge. Whereas an oxygen atom gains 2 electrons to complete the outer shell, which also makes them stable. This forms oxygen ions with a 2 minus charge. And at the end, just to summarize, this shows ionic bonding. Now, continuing from where we were, the charges of the ions can be shown in an equation. So if I had my balanced equation, which is your normal one, so you had 4 lithium and oxygen, this made lithium oxide. Now I have to balance it because oxygen always exists as 2 molecules or 2 atoms in a molecule. Now, what we can see is, as we knew, that when they combined together, they reacted, they formed ions. As we see, the lithium atom becomes a lithium ion, and the oxygen atom becomes an oxygen ion. So this is an ionic equation showing the charges. Now, continuing with the ionic equation, which was this. We can see what's happening to each like element, if you like, just a bit like the exam question. So we saw that lithium atom lost an electron, like this. For example, the 2 lithium ions were formed from 2 lithium atoms losing 1 electron each. So we had 2 lithium atoms this became the lithium ion, two of them. And it lost an electron, so we can put a minus here, 2 electrons. So it lost 2 electrons to become 2 lithium ions. The other way you could write this is you have the 2 lithium atoms again, but they simply convert to the 2 lithium ions and 2 electrons. And remember, electrons have a charge of 1 minus. And this shows they've just split apart into the lithium ion and the electron that was lost. Another example of this half equation would be the oxygen atom forming an oxygen ion with a 2 minus charge. So it started off as an oxygen atom. Then it became an oxygen ion with a 2 minus charge. So it had to gain electrons by doing this. So on the left we add 2 electrons. Now, if you didn't know, these are actually oxidation and reduction reactions. So if you remember the pattern oil rig or acronym oil rig, oxidation is loss, reduction is gain. So we can see that the lithium atoms were reduced, lithium atoms were oxidized, because it lost an electron, whereas this oxygen atom was reduced. Now, using these ions, we can name some salts. So salts are ionic compounds, made up of a metal and a non-metal. So remember that the overall charge of a molecule, like any compound, element, and so on, is neutral or zero. So we need to have the same like positive charge and negative charge, or they need to balance each other out. So the charges almost like determine the formula of a salt. For example, if we use our example again with lithium and oxygen, we knew that lithium is a group 1 element, and that will form an ion with a 1 plus charge, while an oxygen atom is from group 6. It needs to gain 2 electrons and is a 2 minus charge ion. So what we do is we write these out first, lithium and oxygen, and we write the little charges beneath, 1 here and 2. And then what we do is we switch them over, and it tells us how much there are in the salt compound. So in this case, we've got 2 lithium atoms and 1 oxygen atom. So in this case, it's Li2O. But remember, if the two numbers that you switch around after are the same, you just have one of each. For example, if you had magnesium and oxygen, magnesium has a charge of 2 plus, oxygen has a charge of 2 minus. Switch them around, and you still get 2 each. They just cancel out, and you have 1 atom of each. So this becomes like MgO. Now, one more thing you could try with this trick is try and write the formula for aluminium carbonate. So aluminium has a charge of 3 plus, whereas a carbonate has a charge of 2 minus. So if we switch these around, we can see that we need 2 aluminium atoms and 3 carbonate ions. But we need to use brackets here. And it shows that 3 lots of the CO3 are there. Now, ionic equations are really useful for like topic 4, which is chemical changes. So this is to do with your acids. So we've got 3 reactions that you need to know. So when you react an acid with a pure metal, it will form a salt and hydrogen. If you react an acid with a base, it will form a salt and water. If you react an acid with a carbonate, it will form salt, water, and carbon dioxide. So these are general equations. And remember that salts are ionic compounds. And these are made up of usually a metal and a non-metal. And these are also dissolved in water. So you write them with an AQ symbol. Now, some other notes are, before you look more into acids, you'll need to know that acids have a like H plus ion in them and a non-metal ion. And you'll need to be familiar with three of the names and formula of like some acids, such as hydrochloric, sulfuric, and nitric acid. So we can actually split acids into their ions, because acids ionize. This means split into ions. That'll be in water. In this case, you can see that in hydrochloric acid there is one hydrogen atom and one chlorine atom, but they turn into ions instead. So you'll find hydrogen is your H plus ion and chlorine is your negative ion. With sulfuric acid, you can see there are two hydrogen ions or two hydrogen atoms, and the rest is your SO4. That's actually your sulfate ion, and that will have a 2 minus charge to balance it out. And lastly, with nitric acid, you'll have a H plus ion and an NO3 minus ion. This will be useful when you write ionic equations later. Now, continuing with acid reactions, we have some further notes. So there'll be compounds that are in aqueous solution, so they dissolve. I've already said that they split into their ions, so they're written as AQ to show that they're dissolved in water. So as I've said, the following are always in aqueous solutions or dissolved, so they separate into their ions. So any acid we've looked at, salts I've looked at as well. So these are produced from the acid reactions. Now, alkalis are a special type of base. So these are the only ones that are soluble in water, and they're usually hydroxide ones at GCSE. So for example, sodium hydroxide, that's an alkali. And this will split, so the formula is NaOH. This will split into some ions, so we'll have an Na plus ion, because group 1 atoms will form ions with a 1 plus charge, and OH minus. You'll just need to remember this here, OH minus. And remember that ions are free moving in aqueous solution, so remember that's why that these compounds will split into the ions when they dissolve in water. Now, producing salts from acid reactions. So, for example, we have this reaction where magnesium reacts with hydrochloric acid to produce a salt, magnesium chloride, and hydrogen. So the salt is produced from two things. So the metal and the non-metal come from somewhere. So the metal ion is from the base or the carbonate or just the metal itself. That goes here. Whereas the non-metal ion is from the acid. So this gives a clue here. For example, chloric is chlorine, because if you remember, hydrochloric acid is HCl, so it's chlorine, and that goes into the chloride bit of the salt. And remember, like earlier, you can use a switching method to find the formula of the salt. For example, magnesium is a 2 plus ion, chlorine is a 1 minus ion. Switch the numbers around, and you can ignore the signs by now. So you need 1 atom of magnesium and 2 atoms of chlorine, so MgCl2. That's the formula for magnesium chloride. Now, we need to learn some ionic equations from acid reactions. So for example, we have this reaction. Magnesium reacts with nitric acid to form magnesium nitrate and water. Now, what we first do is that we split all compounds in aqueous solution, those that are dissolved in water and have this AQ thing here, into the ions. So we rewrite the whole equation again. We start with magnesium. Now we first come across this nitric acid that's dissolved in water. That's an aqueous solution. So that will split into its ions. But notice we have this little 2 here. So that means there are 2 lots of HNO3. So there'll be 2 hydrogen atoms. So that will form 2 hydrogen ions, each with a 1 plus charge. So we write this as 2H plus, like this. Then we have 2 NO3 ions. So these nitrate ions have a charge of 1 minus, or just minus. This forms. Now this salt here is dissolved in water. So magnesium is in its ion state. So that'll be magnesium with a 2 plus charge. Then you have the 2 nitrate ions again. And lastly, you have just water at the end. Now, after you've done that, you cross out all the ions that stay the same in the reaction. So these are spectator ions that do nothing or don't change in the reaction. So in this case, that would be this nitrate ion here and this nitrate ion here. So what we get in the end is magnesium plus 2 hydrogen ions gives us eventually a charged magnesium ion and just hydrogen at the end. That's neutral. And that's the ionic equation. Now we can split this up, but we're going to try another ionic equation. So let's say we've got this aluminium carbonate plus nitric acid forms the salt aluminium nitrate, because remember, aluminium comes from the base, which is a carbonate also. The nitrate comes from the acid, from the name like nitric, nitrate. And at the end you just get water and carbon dioxide. So first we have the balanced equation as well, and we want to split some compounds into its ions. So there's quite a few. So aluminium forms 3 plus ions, carbonate, so CO3, that forms ions with a 2 minus charge. Hydrogen ions form just a 1 plus, and NO3 just forms a minus ion. So what we get is we have 2 aluminium ions, 3 carbonate ions, 6 hydrogen ions, 6 nitrate ions, This forms two aluminium ions, as well as three nitrate ions, or actually six, because you've got your three here and your two. And at the end, you just get water and carbon dioxide. Now we cross out the spectator ions, the ones that stay the same before and after the reaction. So you can see that the aluminium ions haven't changed. Neither have these nitrate ions here, these NO3s. So we just ignore them now. So at the end we get 3 carbon ions, so 3 CO3, 2 minus, plus 6 H plus ions. They form water, 3H2O plus 3 CO2. Now that's our ionic equation in this example. Now, we then form, let's say, half equations from the ionic equations. So if you remember the acronym OIL rig, so oxidation is loss, reduction is gain. So this is, remember, about losing or gaining electrons. Now, if we link this back to topic 1, I said that losing electrons will make positive ions, or it will increase in charge, or let's say from negative to neutral. Gaining electrons makes negative ions, or a decrease in charge. So here's what I mean by this. So if something is increasing in charge, it can go from 0 to positive, or neutral to positive, or even negative to neutral. This is still increasing. But don't worry if you get this. So for example, I had the ionic equation formed from the task we just did. Now, we're going to write the half equations for these. So to make things easier, assume that the carbon ion splits to form carbon dioxide and oxygen. So let's start with the carbon ion. So what happens to this here? So our carbon ion on the left, 3CO3, 2 minus. Now this will soon become neutral and split somehow. So to become negative to neutral, it needs to increase in charge. So this is going to lose electrons. So for acids, you can just remember things like Nile, which is negative ions lose electrons, and Pg, so positive gain. So in this case, this negative ion will lose electrons, so we'll write the electrons on the other side. Now this forms carbon dioxide and oxygen. As well as, since there are 2 minus each here, 6 electrons. And to balance this, we've got 3 carbons on each side. We've just got to write O as it's on its own, like this. Whereas the hydrogen ion, will gain electrons. So we start with the 6 hydrogen ions. This will gain electrons, so this is reduction. So this will gain the 6 electrons. This will just form along with the 3 oxygen from here, the 3 water we need. So this was actually quite a hard ion, like a half equation setup. Don't forget to practice more of these before the exam, and good luck. Now thanks for watching, and that's the end of the tutorial.